Hello everyone! In this lab, we are going to see some examples on how to use R to compute measures of central tendency and also measures of variation. Okay, so in this lab, we start by generating a vector or list of elements. So let's see how we can do that. We can use the function C in R, which stands for combine, and it can be used to create a vector or a list of elements we want. In this example here, we can see that we have the syntax for combining or creating this list of vector, which is the C function. In this case, we combine the numbers 1, 2, 3, 4, and we are storing the results of that list in the variable myNumbers. And the second line of code actually will display what's the contents of that variable. So let's see the result of that. So we can see here that by doing the C function, we have the output in R as a list of the numbers 1, 2, 3, 4. Now, it's interesting that we can use the C function to combine new elements or add new elements to an existing list. So let's add the numbers 5, 6, and 7 to this list. So I'm going to call my numbers number 2. And we are going to combine the existing list, which is my numbers, comma, with the new elements 5, 6, 7. Okay, now this is being stored in the variable my numbers too. Obviously, let me now display what are the contents of that variable. So let's build. Okay, so the new line of code, as you can see here, give me the output of the previous list with the addition of the elements 5, 6, 7. Now, if what you want is a sequence of numbers, we can use the seq function, SEQ. So in this example here in our lab, you can see that we are generating the sequence of all the numbers between 1 and 40. There is an extra parameter, which is the increment. So we're going to generate all the numbers between 1 and 40 with an increment of 1. So the result is 1 to 30. So now I'm calling the variable to display the results in it. And you can see here that as a result, the variable 1 to 40 has all the numbers between 1 and 40. So let's demonstrate the same function now with another example. Here, let's then create a list of even numbers between -10 and 16. So let's call it even, and we're going to store in that variable the sequence of all numbers between -10 and 16, but because I want even numbers only, I'm going to say that I want an increment of 2. Now let's display the results of the variable. Okay, I have to build. Okay, so now the variable even contains all the numbers as expected between -10 and 16, and there are only even numbers because the increment used was 2. Now, if the list of vector of numbers you want, there is repetition, and by the way, it doesn't need to be only numbers, but there is a repetition, we can use the rep function to build that list. So here you can see that in this example, we have a repetition of the element 10 5 times, and the element 1 11 times. So the result is already displayed. You can see here that the number of 10s 5 times, the number of 1s 11 times. If you intended to combine these repetitions into a list, we still can use the C function. And here you can see that's basically combine the two repetitions above. Let's now display that. So all Together now is the name of the variable where we store that. Let's build the R markdown file so we can see that display. So you can see now that the result of all together now variable has 5 tens and 11 ones. We also have commonly the task of tabulating data in a statistic, meaning we commonly want to create a table with the frequency of all elements in our data set. So one way of doing that in R is by using the table function. So with the variable all together now, we have already the repetitions known, but let's confirm that indeed the table function in R will demonstrate that frequency for us. So we have table and the parameter is our data set, which is all together now variable, and it should be already displayed. So here it is. So when you ask R to display that, it counts the element 1 11 times, so the first column represents the repetition of what element, and the second column as well shows that the number 10 is displayed 5 times in that data set. We also are interested in many of our computations in statistics to add the elements in a data set. So we have the base function in R called sum, and when you call this into a particular list of elements of a data set, that's going to add all its elements. So we generate a new variable called 1 to 100, which is a sequence of all numbers between 1 and 100 by an increment of 1. And we are asking R to add all these numbers. So you can see here that the result of the sum for the numbers between 1 and 100 is 5050. We sometimes need to know the length or how many numbers are in a particular data set. So if we have a list of elements, we can use the function length. By the way, the function length appeared also in our previous labs. So here you can see that we use it now to count how many elements in the list of numbers from 1 to 100, and as expected, the outcome of this function is 100. Okay, now let's take a look at one of the main topics of this lab, which is measure of central tendency. So there are 3 measures: mean, median, and mode. For the mean, we saw in lecture that to compute the mean of a data set, we add the values in that data set and divide it by the number of values in the set. We're going to take as an example our variable 1 to 100 that we used in the example above. In this chunk of code here, we add in the elements of the variable and divided by the number of elements in that variable. So since we saw above that the sum is 5050 and we are divided by 100, we expect that the mean for this data set is 50.5, which indeed it is. Now, obviously, this is one way of computing the mean, but R itself also provides a function that does the computation for us, and the function is called mean. So we can ask R to compute the mean of the elements in that data set, and you can see here that the result, the output is like the same. The next function, we have median. We know that median is the element that sits in the middle of the list in the data set, the list of elements. So R also provides the functions for that. So if we call the function median into a list of elements, say 1, 2, 3, obviously the element 2 is the one that sits in the middle, and we can see that the output for that is indeed the element 2. The other measure of central tendency is mode, and mode is the element with the highest frequency in the data set. Now, R doesn't have a function for that. It does not provide a function for that, but by searching online on Stack Overflow, we found that there is a way of creating a function that does the job of finding the mode. So in this chunk of code here, we are creating a function that has a certain input x. X is going to be basically replaced with a list of elements. That function has a name called myMode. What it does between the braces, it basically look for the unique elements of the list given to the function, discount repetitions, and then once it has these unique elements, it's going to match the elements with the tabulation, which basically is the frequency of these elements, and decide which one has the maximum frequency. So in this example here, we are applying this new function, myMode, to the list of elements that contains a bunch of ones, the number 2, the number 3, and 4. Notice that there are repetition for the number 1 and also repetition for the number 3, but obviously number 1, because it has the highest frequency, is the mode. So we have that the output of this is indeed the element 1. Now, let's create another example here where I'm going to ask for myMode of the list rep. We're going to take repetition of the number 2 19 times and combine with the repetition of the number 4 5 times. So by definition there, 2 should be the mode because it's most frequent element in this list. So let's now build this. You can see here that the outcome for myMode function of this list with repetitions of 2s and 4s is indeed the element 2, because the element 2 repeats 19 times, while the element 4 only repeats 5 times. Okay, now let's take a look at the next topic, which is variation. There are 3 types of variation measures we cover in lecture: range, variance, and standard deviation. First, let's take a look at how to generate a distribution so we can see how these functions can be computed in R. We are generating a normal distribution, so R norm generate this normal distribution of 100 elements or 100 numbers. These numbers have a mean of 10 and a standard deviation of 5. So we plotting also this distribution. So the result is this. So we have this distribution of a normal distribution. R has a function called range, but that's not the same thing as defined in our textbook, in our lecture. Range for us is the difference between the maximum and minimal element of the data set. The function range in R gives the maximum and minimum elements, but not the subtraction of these two values. So let's see the result of this. So we can see here that for our distribution, we have the range given by R. So the output is negative 1.187835. So this is the minimum element in the data set out of the 100 elements, and the maximum element in the data set is 24.856461. Okay, so now let's see how we can compute the textbook range. So let's say here, let's call this and store in the variable R1. We're gonna display R1. So it's going to be composed of 2 numbers. It's like an array output. So that is the first element of that output, and there's the second element of that output. So I'm going to name my next variable textbook range. And for that, I want to compute R1 second element. So the indexation is done in brackets. So I'm going to do R1 second element minus R1 first element. Remember, the second element in the list is the maximum number, and then the first element is the minimum numbers. Also be sure that we're gonna display that result. Okay, so I'm building the RMT file. Okay, so please also notice that because our norm, the function that generates our distribution, is a randomized function, the fact that I build again the RMT file, generate a new distribution, update that distribution randomly. And of course, with these new values for my distribution, I have a different value for the minimum. Right now, that is negative 1.765662, and the maximum number is 27.332481. So the subtraction of these two numbers, which is going to be something around 29. And indeed, you can see here that the result of that subtraction is makes sense, right? So if we want to define the range as in the class, we need to do an extra step. And you have to remember that for R, range means just to giving the output of the maximum and minimum numbers. Next, we have the variance. R has a function for the variance, var. In the parentheses, you input your distribution. In our case, we're still using the same distribution sample numbers from above. And you can see here that R output the variance for that distribution. Please note that that is the variance for the sample. So basically, R does the computation. It divides the result by n minus 1. We also have now the standard deviation, which is the function SD in R. And again, this is for the sample standard deviation, so it's correspond to a division by n minus 1. We also computing the standard deviation of the same distribution, so the result is 5.021379. Please remember also that the standard deviation is the square root of the variance. So if we ask the square root of the variance of the sample distribution we have, we're supposed to get the same result. So you can see here that for the square root of the variance, we also have 5.021379. Now, we can ask all of these measures together. So let's say I want to actually to obtain all the descriptive statistics that we learned so far. So again, I'm asking R one more time to generate a random normal distribution. We're going to still use 100 elements in that distribution, and these elements have a mean of 10 and a standard deviation of 5. We're going to add all these elements. We're going to ask what's the length of this distribution, and again, the output should be 100 because that's how we'll build the distribution. We're asking also what's the mean of the distribution, the median. We're still using the same define my mode function from above. We're asking what is the maximum and minimum values of this distribution, which is the range in R. We also asking the variance and the standard deviation of distribution. So the output of all these measures, as you can see here, all descriptives, are indicated as. Please note that once we run again the RMD file, we build the file, the rnorm function, which is a randomized function, will again select randomly numbers to compose our data set. Therefore, I have now different values for variance and other measures. So we just learned how to compute measures of central tendency and measures of variation in R. Now, if we have a single variable with numbers, that's kind of straightforward as you saw in our examples. But in reality, most of the time we have a big data frame, a table with different, let's say, groups, and each of this group has different values or numbers. Or we can think also different conditions, and these conditions have different values or numbers. So if we have to compute these measures for different groups, we can do that also in a more efficient way with R. Now let's see how that works. First, let's generate our data frame. So here in this chunk of code, we are generating 100 scores, and these scores have a normal distribution with mean of 10 and standard deviation of 5. Let's also assume that we have different categories or conditions, and these conditions are represented by A, B, C, D through the letter J. And we have 10 of each. So the code in R, we're going to have a repetition of the list of these letters where each of these letters has a repetition equals to 10. So notice that is each equals 10 as an extra parameter for the wrap function. So it's not just repeating, but I'm telling how many times I'm going to repeat each of those letters. Now, my data frame here, which is going to be stored in the variable my underscore df, which is the data frame I'm constructing, has these conditions aggregated with the scores. So notice that we have 10 letters. Each of these letters repeat 10 times, so a total of 100 of them. And for each of them, we're going to have one score associated. All right, so let's take a look first at our data frame. So let's display that. Okay, so quite a long list, but here's give you the idea that our data frame has these conditions A with several scores, 10 in total for condition A. We then have condition B, also 10 scores associated to that, C, and so on. So there is a total of 100 of them. Okay. Now, if I want to compute, let's say, the mean for condition A, the mean for condition B, condition C, and so on, obviously we can do that in different ways in R. One slow way of doing that, and we have this in the chunk of code right here. So notice that I want to compute the mean of, inside the parentheses, I have to instruct R which parts of my data frame I should be using. So there is my data frame, and inside the bracket you put what part of the data frame we're referring to. We're referring to the part where all the conditions are equals to A. So notice to tell this to R, we again repeat my data frame, $, and we refer to when the condition is equals to A. So that's just hey, we're looking at condition A. Notice the comma as well. And from that part in your database, then you take $, the scores. And you repeat the same thing for condition B, repeat the same thing for condition C, and so on. So you do the same work for each of the conditions. Obviously that would be slow, but we can see the result right here. So we have the scores in condition A is 90.8 and change. We also have a mean for condition B and a mean for condition C. Now, this is not ideal, and R is such a powerful tool that it has better ways of doing things, right? So we already used before the dplyr package, which help us to manipulate data frames. So that's the purpose of deploy. So we're gonna again deploy this package one more time, and we're also gonna use the same functions that we used before in our previous lab when we were graphing data. We use group by, and summarize functions from the plier package. So here's our next chunk of code. Notice that I have to load the package into my workspace so I can work with the functions in that package. So library parentheses deployer is how we do that. Again, nothing new here. I'm referring to my data frame. There is a pipe saying that we are going to group by conditions. Once we group by conditions, there is another pipe that say we then summarize values there, and how we summarize, we're going to call these values means, and this means for that particular summary is going to be equals to the mean of the scores for each the conditions. Okay, so when we do that, notice here the output, we have a table where for condition A we have a mean, and notice that the mean up to 2 decimal places is the same as I mentioned before when we were doing the single condition code. Not so efficient, but the number would come up to be the same up to 2 decimal places. And then we have the similar result for condition B, C, and so on. All right, so now we have all that. So this is more efficient because now I'm telling all at once, work with all conditions, and for all the conditions, each of them you're going to compute the mean. That's basically what we're telling R to do. We are going to see that there is a better way of displaying the results of the table. In R, there is a package called neatar. So neatar is the package that builds the RMD file. We do not actually use that package because it's already built in the CoCalc platform. But neatar has a function that will help us to display better the results of the table. So we're going to call neatar with the sub function cable. So the code is still the same as before. So we have our summary data frame where we put the summary of the means according to conditions into this variable summary data frame, or summary underscore df, and we're going to ask neatar to cable that data frame for us. So the result, as you can see, if you compare the two tables, the one on the top and the one on the bottom, the one on the bottom better display the results. We also can aggregate different descriptive measures, different descriptive statistics together. So instead of just asking to compute the means, we can ask also the standard deviation, the variance, the range, you name it. So let's take a look at that. So here is our modified chunk of code. Notice that the first part is basically the same as before, but in the summarize function, now we add an extra parameter, which is compute the standard deviation of the score as well. So comma SDS, the standard deviations of the scores, and we're still displaying this with the cable functions in neatar. So we should have an extra column, and we do. Notice that now you have a column for the means, and we also have a column for the standard deviations. Let's also add the minimum and the maximum of the scores. So the display is just going to add 2 more columns, and we do have a column for the means and a column for the maximums of the conditions. For purpose of our lab, to work again with the Gapminder data frame that we worked before. So we're going to load the data table package that we saw in our previous lab. With that package, we can call the function fread, which is going to read the CSV file that is contained in the folder for this lab, and is the same file as before for the Gapminder. And that is going to be read in the variable Gapminder df, our data frame. So Gapminder df, as you can see here in the display, so the first column, which it doesn't have a name for that variable, is just the ordering of the data values that we have in each row. There is a variable called country. There is a variable called continent. There is a variable called year. There is a life expectancy variable. There is a population variable, POP. And there is a GDP per cap or GDP per capita, also another variable. So what we want is to provide descriptive measures for life expectancy by continent in the Gapminder data frame. Okay, so we have our data frame that was constructed above. We are going to use the group by functions from dplyr and group by continent. The other pipe in this code says to summarize the results for life expectancy. So we want the mean of the life expectancy. We wanted the standard deviation of life expectancy. We also wanted the minimum and maximum values of life expectancy for each of the continents. And we're going to display that in a nice table using the function cable in initR package. So the result is here. So for each of the 5 continents described in our data frame, there is a mean, there is a standard deviation, there is a minimum value, and a maximum value. So now with these tools, which is a combination of new things like the mean, the standard deviation, variance, how to display this in a nice table with the initR cable function, combined with the package dplyr functions, which allowed us to group and summarize the results for a data frame. You can now proceed and complete your lab. Good luck.